Okay, thanks, and sorry, really I'm late. I had a bit busy day. I was still making this PowerPoint while I'm here. So, but anyway, I don't talk now much about myself since I'm late, but I would love, but anyway, I skip that part. So the topic is collision and animation systems in games. So I didn't really think that much when I even choose the topic. So this is a bit mixture of different subjects, but the main idea would be just to give overview and then some maybe connecting points between the topics and also physics integration. But let's see how it goes. One thing with collision systems is that it's actually much more useful than just finding plain collisions between or contacts between different objects, because you can use it for a variety of purposes in games. So one subject is shadows and other visual stuff, when you need to basically narrow down the number of objects and number of polygons where you are applying different effects. So you can use collision systems for also performing visibility probing from the scene. And AI is also one important part of collision systems. So you can, or other way around. So you can actually, the AI can use the collision system for finding different information about the environment where the AI is working. So of course, like classical example, that AI can see if, or check if it can see the player or not. But not only that, for example, AI could even use the collision system for navigating. So many times, or many games have used collision system to build basically navigation net over the whole game level. So you can basically building like navigation points automatically based on collision system. And camera is also like similar use. So basically finding out in third-person games, camera is usually done so that you have the camera starts at the player character, and then it backs up maybe a few meters and goes up a few meters. So the collision system is used for making sure that the camera stays inside the level and doesn't intersect or go through the walls in any case. But also the camera could use not only the movement collisions, but also just like probing basically, like how near the walls is, for example, that it could like make the camera closer to the character and that kind of things. So in some games, game camera doesn't use collisions only for the one movement, but maybe like 10 to 20 different rays or line segments cast from the player. So just like basically learning more from the environment. And then triggering is one like basically way of building up the scriptability and the gameplay with the game engines. So you can define areas and volumes inside games which you can trigger different events. So for example, many times, even if some AI looks very smart, so it reacts to the player, it might be just like basically like smartly put objects inside the game level, which actually tracks how the player is moving. For example, the player there could be a basically dummy box which collides against the player, and when the player reaches the box, there could be some script which checks that if the player is running at this point, then you could trigger the alert of the enemy guard. So you can do pretty much of the AI stuff also with the scripting and collisions. So you can actually kind of like move the intelligence from the actual AI players to the level, which is quite nice, since then you can customize it more. And also for cutscenes and that kind of stuff is quite straightforward how you can use collision system. So as with everything else, it's a good idea to simplify the collision problem as much as possible, because usually when you start thinking like characters have moving arms and things like that, it's pretty nasty quite fast if you really start to like trying to model any nature in that sense. And there is some university research with like really like moving parts of human character, but it's usually you can get away with much easier shapes also with other game types than third person games. So the scenario simplification is you can use simpler shapes as mentioned, but also you should first of all try to minimize the collision checks which you need to do, because it's usually there is much less to check than what you would think at first. I'll get back to those two later, actually quite soon. But anyway, the benefits of simplifying is of course like very clear, that it's simpler to implement and better performance and also more robust, because it actually might work. So, and also in some cases you can even avoid collision checks totally. So for example, some car games have basically used just like distance to the racetrack center line. So you don't check any collisions, but you just check like if you are more than X meters from the center line, then you are driving on the grass. And then if you are driving a bit more than that, then you are colliding against something. So you might even like basically could get quite good results without any collision checks, which is of course the best case. So about the minimizing number of checks. So there are usually when you think about the game world and what kind of objects there are. So you have player characters and vehicles and bullets or projectiles in general. So shells and bullets, and of course the game camera or cameras, and maybe some dynamic level geometry like elevators and that kind of stuff. Then you can usually also start to think how you can minimize and what objects actually need to collide against each other in practice. So the camera is maybe the simplest case, because you can basically collide it only against level geometry, and then you get already a pretty good results. And nothing traditionally collides against cameras in games. So that already eliminates a lot of collision checks, because if you think that you have like, let's say like 100 objects in normal game room or whatever unit, then you end up with basically 10,000 collision checks if you just brutally check each other against each other. So, and also same thing with characters. So characters don't collide against camera, and bullets especially don't collide against each other. So bullets you can usually handle like very much special case. So you could even define that the bullet trajectories are actually instant when the bullet is shot. So you can just check the collisions right away when the bullets are fired and forget them afterwards. And using them just for visual stuff. So that might be even simpler. But also it's more general, like also with weapons. Weapons are usually separate objects from the players, because you need to be able to drop the weapons and pick them up, and maybe you can even hit the weapons in some cases, like with bullets. But still, there's like games have many objects, and most of the checks are really really unnecessary. And one thing is also that you don't necessarily even realize that you are doing too many checks, just based on the like thinking or how you when you implement it. So and also with racing games, normally in racing games you can't drive over other cars, so you just might disable like tire collisions altogether with when colliding against other cars, or then depending of course on your like on the ground and the level environment, but you might also disable hull or the car hull collisions when checking against an environment if you have big enough objects. So you think that just checking wheels is enough for the cars. But anyway, this already like minimizes basically most of the collisions away. Then there is basically simple way to implement this kind of filtering and categorization. So you basically have each object categories. So you have characters and dynamic objects and camera and whatever. And so basically one bit for each object, if you want to think it that way. And then you define for each object what groups are collided against. So you have basically like 2 bit masks, which is like ends up very simple check, and you can handle like game collisions in fairly generic and very efficient way. So basically you end up with checking if each category can collide with the categories defined by the other objects, and other way around. Then about simplifying shapes after the number of collision checks are minimized. So you can usually simplify almost anything with a box, but of course it's better if you find some more appropriate objects for each approximation. So basically character can be in Quake games. I think the character has been box traditionally, but cap, cylinder, or like capsule shape is pretty good for various reasons. I'll get into those next. But car is like basically box for hull, and then the 4 spears has been quite traditional for tires. Actually, you might wonder like why it's like a sphere instead of cylinder for tires, but that's because you probably end up with better looking behavior with spheres, since then you can go over like small obstacles also in vertical direction when compared to having just mathematical cylinders on the spheres. So sphere is pretty nice object in that sense. Then there are other like third person or even racing game objects like camera sphere. So it's pretty nice approximation, because then you can make sure that it stays within like some reasonable distance from each wall, and many third person games don't have like really too sophisticated cameras, so you get pretty far by just like shooting the camera behind the character a few meters with properly sized sphere, so it doesn't look bad at least. Then bullets I already covered basically. So either it depends on the application. Like if you have like very fast moving bullets, you can just use line segments, or either if you have very big bullets, then just spheres. But anyway, simpler to approximate those. And these have other benefits too than just like performance issues. So I'll get into the characters and something else I forgot already, like next slide. But then also 2D is interesting, because even in 3D games you might might be able to use 2D quite efficiently, because in many games you have very little actually 3D movement. So for example, a game like Hitman, you don't like basically ever jump on over one character. So you can do fine with just 2D collision checks. And if you think about two characters colliding against each other in 2D, then it's basically just a circle colliding against another circle. So it's just like calculating distance between the two and then keeping them apart. So it's even better if you can avoid 3D altogether. And many times it's really unnecessarily. Also in racing games, many times cars can't jump over each other. So basically boxes in 2D is fine for that. Yeah, so now more details about this character collision. So this is the basically the approximation for the character capsule, and also the capsule doesn't. It's just comprised of or consists of two spheres and the cylinder, and it's also like other benefits than just like simplifying the implementation and gaining some performance, because of the symmetry, like make sure that when you are walking in the environment, then you never end up in a situation where you can't back up. If you think that the character would have, like for example, shoulders, so it would have, if you look at the character from top, it would have different dimensions in shoulders and the front, then you could get stuck quite easily by strafing, for example, to some corner. So it's also gameplay-wise better that you have some fairly symmetrical approximation, at least when it comes to moving in the level. And also stairs and other small obstacles. So if you are walking up the stairs, you need to handle it with some special case. For example, like if you have a box, you need to handle it with some special case. So some games I know have used box as character approximation, and then they have, when the player is moving forward, they try to move the character box up a bit, so they can check that is it like likely on some chair or not. So, stair. So it's a bit like you can of course do it that way, but with capsule the nice thing is that it kind of automatically handles all the small obstacles, like small stairs and that kind of issues. And that circle thing also was handled all described already earlier. But even if you would have 3D collisions, you might be able to just, for example, ignore the two upper spheres and handle only the capsule or the cylinder in the middle when colliding against two characters. Or then you could ignore the cylinder in the middle or handle just the two spheres with pretty good results probably as well. So you can usually fine-tune most of the collisions by eliminating unnecessary checks quite far. Then there is the level geometry, which is special case in that sense. Also with characters, actually, if you think about like level geometry, fine, you can collide against with the capsule and even other characters. But of course the difference is, or the special case is bullets. If you think that bullets would need to hit actually on the character shoulder or character arm, and not just the capsule. So you need to have special or separate handling for each type of collisions, depending on the actual object. So for example, with character, you would first check if the bullets hit the actual capsule or the sphere, and then go into. Then you would have maybe computed like bounding boxes of each bone of the character. So you would have some kind of box representation of the moving character in the world. So then you would check against each of these boxes, and after the box has been collided, then you would go in the polygon level. So using like a simple hierarchy for minimizing the checks. And most of the time you don't even need to go in the polygon level, because then you can just like make, for example, if you have some blood splatter or that kind of thing, then you can just like display it on the whatever position it hit on the bounding box of one bone, and it's pretty good chance that there is no difference, because the bone bounding box usually is pretty accurate on the actual skin also, and when you hit characters by bullets, it's like quite far anyway, and even if it would be quite close, the whole event is very fast. So there is not that many cases where you would actually be able to tell any difference, and usually the polygon level access is much slower than checking just against some boxes. And also with modern games, usually you have so many bones in each character, so you can have like 50, 80, even more than 100 bones in one character. So when you approximate collisions with bones, it's nothing really too inaccurate for almost any purpose. But then when you need to really go into polygon detail level is the level or the environment collisions. So, like some cases you can maybe avoid the polygon checks, but it's probably more exception than usual. So the racing game, like simple racing game example was one, but for example in Quake or third-person kind of games, you really need to collide against more detailed shapes, and the problem is that with all this bounding box and bounding sphere and bounding box hierarchy and whatever approximations, they always like more or less approximate the objects from outside. So level geometry, you are really like moving inside the object. So it's definitely separate case to think about. But when implementing, of course, if you are using some separate or third-party collision library, then it's different case. But whenever you are implementing collision checks, you should make the single polygon versus the object collision very robust first, because basically everything else, like what Quake has used, like PSP and other games, many games use like portals, so they party on the world to cells which are connected by portals, and then each cell has own PSP. So all that stuff is basically, it's just optimization for eliminating the collision checks eliminating the number of collision checks as small as possible. And it's surprisingly difficult to make basically any shape, even sphere, check against a single triangle very robust, because there is very number of issues with also with floating point value accuracies, which make it very tricky. So basically the one problem is that when you approach a polygon very narrow angle, then you end up in a situation where you are basically inside some polygon with the shape you are checking, and then it's quite problematic, because you can't really move the polygon either, or the object either, without the possibility of causing it to go inside some other polygon. So So it's quite tricky and good exercise to do that first. But of course, in actual game or whatever you are implementing, you need to then later you need to add the tree structure or whatever structure you use. For example, that cell partitioning thing to speed up your collisions. But you should really do it this way, that you do it first with single polygon or list of, you could even check against all polygons in the world first and check that everything just works. Because with these street structures and stuff like that, they usually tend to also mask problems, so you don't necessarily see that it's actually some very low level collision or intersection test which actually bugs, because there is all this fancy tree stuff above it, so it might hide a lot of problems as well. So in general, it's good to test from very low level stuff first and make sure those actually work. Then it's more like matter of taste and game which high level structure you use. So if your worlds are like mostly consist of rooms, like very clear rooms and some doors and windows connecting them, then you are pretty safe by using portals and cells and maybe having PSP for each room. And then if you have more like random, maybe some, if you have landscape environment, then you like most definitely want to handle the landscape in some different or some special case from the other structures. So it's quite much dependent on the game type. Also, many games you might be able to do with at least partly 2D collisions. So for example, in a formula game, you don't necessarily collide against anything which is either you collide with something which is on the ground, or you don't collide at all. So that's also one thing. Like the 2D aspect is also one thing to consider on the topic. So, but those are pretty like most common. Like PSP is just like you divide the world just like recursively to two parts, just to eliminate the number of checks when you actually are checking collisions against the tree. So when you have always the plane dividing the world into two, then you can very easily check which side of the plane you are, and do you need to check against the polygons of the other side. And basically all of those are like more or less variations, not necessarily variations of the PSP tree, but variations of the same idea. So you divide the space, for example, in Octree you divide it to eight parts and then check which part you are in and which you need to check against. And OBB is like oriented bounding box tree, where you have like a tree of bounding boxes which goes always like smaller and smaller detail, maybe even in the polygon level at the end. And AABB is like axis aligned bounding box. So same thing, but all the boxes are axis aligned, so you can check them faster, but maybe end up with more loose boxes. So it's like very case dependent. And hash tables and hash maps are also like very useful in many games. So if you have some higher level game structure or game world structure where you can basically like world map, then you can pretty efficiently use some kind of hash or map structure and to get very fast like the coordinate where you are in the map and what can happen at that point. And of course you can combine all of these. So for example, like you could have hash map of different cells in the game, and then just pick the one where the player is and use some other method, maybe like PSP tree or Octree inside that one hash map cell. then, well, the collisions are somehow like more important than animations, at least like gameplay-wise, because you can usually have quite much gameplay in not really like playable, but you can have quite much functionality in a game with just having all the collisions and triggers and AI and whatever working, but of course it doesn't look like game if you don't have animations or graphics there. But this is just like basically some considerations when you start integrating animations and an animation system to games. So some requirements, like for example, if you have a third-person game, you need to be able to aim and shoot with firearms and different weapons. So for example, how we could do it is to first play back some shooting animation, and then find out the position of the hand and place the weapon there and aim it and then find out the target and maybe fine tune the target or the weapon towards the target. So this is already very game specific, and same thing with movement. So many games have used just basically linear or more or less linear movement with characters. So when character starts, for example, walking, it has some specified predefined movement speed for the walking and running and so forth. But if you really think about moving in that sense, it's not like linear movement. So for example, walking, you really move forward more in certain phases of the animation. So if you use just like linear speed for that, then you end up with the feet slipping also. So basically this means for the animation system that we need to be able to find velocity of individual keyframes and individual objects in the hierarchy. And of course, like when in third-person games, you need to be able to shoot and walk at the same time. So that also causes a requirement that you need to be able to animate different parts of the character separately. So usually this is done so that you have basically some primary animation which defines the animation for the whole body, and then you have some specific animations for at least for upper body. So you can have aiming and picking up, opening door, and that kind of animations, which are applied only for some bones or like upper body bones of the character. Then in racing games, this is a bit different kind of animation, but you might, for example, want to animate tire textures based on the car speed. So you might want to put some like more blur textures when the car is moving faster. So these are already like the random basically notes about animations. But the point is that you need very low-level access to everything when you need to change textures and find out some speed of some individual keyframes. So not very generic animation systems or very like black box systems doesn't necessarily work too well in practice. And also note about animations important note is that it's like many animation packages like 3ds Max, you have very strict one animation per object, at least like in the versions which I have checked. And in game it doesn't work like that, so you can have a single object can have many animations, and sometimes it doesn't have animation at all. And also single animation can be used by many objects. For example, in many third-person games, you have basically female and male like skeleton animations, and then you have special cases like some drug addict animation and whatever. So you can get away by much fewer animations than you have actually characters in the game. So then you can share much more data between each characters. different characters. So from these notes basically, you can already guess most of the requirements. So you need to have some kind of support for hierarchical animations. So each character have insane number of bones, and you need to be able to control it some systematic manner. So each character has one root bone, and then you have arms and like the spine and whatever bones you need. But also you need very low-level transformation access. So from your animation system, it's not enough that you can say that play back this animation to this and this frame or this and this time. So you need to adjust like animations, like which part of the body you apply. For example, like the upper body, lower body case, or the head turning or face animating in the character. And then of course, like which objects you apply. So it's not really some 3ds Max scene which you are animating. It's really like depends on the case. And this is also why many times, like even like in real life games, animation systems tend to be too much modeled after 3ds Max. So you have like, for example, you might have animations embedded inside objects, which is more like or animations like directly associated with objects, which is like more 3ds Max and modeling package case. But in game, you really have, they are like completely separate from the actual scene, which is animated. And also animation blending, which is of course in some way bad. You should also always like have some transition animations if possible, because blending usually causes artifacts with the movements. And but you need to be able to do blending still. And also like from the example of aiming. So it's not enough that you say that I want animation to be played back to this time, because you need to be very carefully in games to be able to control like when the animation is applied and what is done to the object before that and afterwards. So you need really like quite low level access to animation data in games. Then more example of this character walking. So you can do pretty nice character system by like having simple states associated with different character animation and different character states. So basically, if you start assuming that the character is idling, maybe just standing and hanging around, and then character or the player presses forward and character starts walking forward, you need to somehow change the walking animations. First thing is of course like which comes to mind is that you blend the walking animation. But usually, like if you can use transition animations, it's better because for example, when you are crouching down in the ground, if you just blend it to some different, like let's say walking animation, the poses are very different from each other, and then you end up with situation that your feet, for example, goes through the ground when it should really like be really separate animation. So when you think about the animating character, you should always think also the transitions, how the animation is actually started from some different animation. But this of course explodes quite easily. So if you have, let's say 40 different states like idling, walking, sleeping, whatever, and then you start building different transitions for each of the possible cases, then you end up basically like 1,600 different transition animations. But of course you can, like for example, assume that when the character is sleeping, it always transitions to sitting animation first, and then transitions to standing animation before doing anything else. So the transitions are basically probably the most complicated thing with the character animation. So, and many times you just like forget them. So oh shit, like this was I didn't think about that. This transition can happen at some point. So for example, like if character is running and character can jump, so can character shoot and jump at the same time or not? And if it can, then what happens to arms? Because you should animate arms too when the character is jumping. So it's not only like programming problem, but it's also like game design problem. And many times you get some very vague descriptions from game designers. So you need to improvise quite a lot when implementing the stuff. So. Other topics, those I basically all covered already. And that's basically it from those. Oh yeah, I have some animations. Too bad there is like this grid below the character, but it doesn't show much on the screen. But basically this this shows how the animation speed, it doesn't have anything defined on the actual in code. So all the movement of the character is extracted from the animation data. So that's how too bad the color is like that. But the foot don't slip anyway, because the character is actually moved based how the feet move relation to ground. So it calculates movement of each feet and then averages that, and then applies that movement or velocity to the physics system and moves the character capsule in the world. But it's good to put some like time basically, or a lot of time to make the walking and that kind of basic movement very good looking, because then you end up with because that's what mostly anyway player is watching when he's playing the game. Then if we add aiming and shooting to the scenario, we do a couple of simplifications first. So we assume that the character is mostly aiming towards the direction where he is shooting. So this is quite natural assumption, even if it's like it simplifies it a lot. But if you really think about it, like if you are shooting somebody, you probably turn your whole body to the direction where you are shooting. So it's easier to. I haven't done shooting much, but I bet it's easier to aim if you really aim with your body and not only with your arms or upper body. And so with this assumption, we simplify the scenario a lot, because then you end up with basically up, forward, and down directions only. And this is like, and then when you think about interpolation, and you need to just calculate the angle where the target is, or how much the camera in third-person games. Basically, the camera works so that the character always shoots where the camera is aiming. So when basically the crosshair crosshair is always in the middle of screen, and then the character is just like shooting where the crosshair is pointing. So then you can have even like the tilt of the camera directly as input for the blending of the aiming up, aiming forward, aiming down animations. And then you can, because you have only two of them active at the same time, like forward and down, for example, then you can just linearly interpolate between two, and you end up with a very simple system, and it still looks reasonably good. And also like to know that you need to apply only to part of the bones, so only the upper body bones. So you can still walk and even jump at the same time. And then, because of course this aiming up, aiming down, and aiming forward doesn't like completely match the direction where the crosshair is pointing. So then you need to, or easiest way is to do is to just adjust the weapon direction. So you pick up the transformation of the hand and then calculate the direction to the target, and then build a new transformation for the weapon based on that direction, because then you probably know like which is the up direction in the world, and you need to keep the or the weapon aligned up anyway. So you know up direction, and you know the target direction, so you actually know exactly how to position the weapon. So the last axis is basically just cross product of the two previous. So then you can have or weapon pointing directly to the target where the player is shooting. Then I have another animation. I hope I recorded some up and down shooting also. I'm not sure did I do that. I guess the only shooting was in the start, but anyway, this shows a bit so that you align the weapon based on the direction where the camera is shooting. It's also very very intuitive, of course. To basically the controls in most third-person games is just or in PC. In console it's different, but in PC you have just like basically just Quake controls, so the player is shooting where the camera is pointing. Then, which was also shown in that animation briefly, was the physics stuff. So those are kind of separate things. Like collision system finds out the contacts or contact joints between different objects and feeds them to the physics system and physics engine. And the physics engine might have some other joints like some hinge joints and whatever motors there, and then it solves the object positions based on that input, and of course velocities or momentums. And then the rendering and everything all of those are basically separate, and the game basically integrates everything. So game uses collision system, game uses physics system, and game uses rendering, but all of those don't necessarily need to know anything about each other. The biggest thing with physics is that it changes the main loop, because traditionally if you update objects, then you say like this velocity of this and this object is something, and then you update the position. So with physics engines you don't actually update the positions, but you set the linear or you set the velocities or even forces on the object. So you don't actually control the position that directly. So and let the physics system to solve the positions. So this can affect a lot depending like how you have done your game updates and game loops, because if you use some kind of collision information and movement information already in the same loop, then you are basically in trouble, because all that information comes only when all objects are updated. So this structure, this affects quite much on the structure of the game. Usually it's not a big deal if you take into account already in the first place, but But if you just do the game loop in traditional, or game updates in traditional way, and then try to integrate physics afterwards, it's much more pain to do. And with characters, for example, with player characters and other there is some special cases which you need to do. For example, like player character needs to be always facing up in the world, so you need to align the player capsule with the world up axis. Yeah, and then some advertising of the book. So that's pretty much it. So collision-wise, simplify everything, and then animation-wise, don't build anything too fancy because you need the low-level access anyway, and two like black box systems might not do it, or probably won't do it for that. And that's pretty much it. So then the book should come out like in a month or so. I don't know. It takes forever to print. So I haven't seen yet myself a copy of that either. So I'm just counting on it that it will come out someday. And it was quite interesting project too. I mean, it's funny to speak about some project, and yeah, you should have a good process for game development and stuff, and then you do the book basically so that we were writing the book basically very much separate, so we didn't read the other guy's stuff before almost the whole book was finished, but it ended up pretty good anyway, so I'm quite happy. We were making also game demo for the book, and it was a bit less than what we had planned. We planned to have everything like AI there and everything, but let's see, maybe we'll add more stuff in the future to that. And I guess that's pretty much it. So now I'm working nowadays for Pixel Scene, which is doing a bit this and that on game. We have some own projects on mobile and handheld, and also done some consulting and that kind of stuff. So if you are looking for a job, drop email or me or that address too. So yeah, but I guess thanks for listening and see you later.